Hello, welcome to the session of CAT 25 Quantitative Aptitude. We are going to cover algebra in this session, and in algebra, we are going to cover inequalities. So, what I can say that my name is Shashank, and let's get on with it. Now, let's understand what is the underlying principle of algebra or inequalities, and solve few previous year questions of inequalities that we have seen in previous year CAT exam. Okay, so basically the basic concept of algebra is inequality is let's say let me start with the linear inequalities, then I'm going to talk about polynomial inequality. So if I'm going to talk about linear inequality, and let's say x is less than y, and that is given to you, so I can say that x plus k is less than y plus k. Okay. Second is x minus k is less than y minus k. K is any number. It can be positive, it can be negative, it can be a fraction, it can be irrational, it can be irrational. It's perfectly fine. Now xk should be less than yk. But when I'm talking about this, it comes with a condition that k should be positive. If k is not positive, for example, k is negative, then inequality reverses. So it is xk is going to be greater than yk if k is less than 0. Now, how it is so? So let's take an example. So 2 is less than 3. So x is 2, y is 3, right? Now let's multiply this whole thing by 2. So I'm going to get 4, 6. Is 4 less than 6? Yes. So if k is positive, my inequality holds true. Now let's multiply with minus 2. So we are going to get minus 4, minus 6, and minus 4 is greater than minus 6. So inequality reverses. So when you multiply or divide a number in any inequality, always remember you need to know the sign of k, or you need to know the sign with which you are multiplying or dividing, because if you don't know the sign, you don't know whether inequality will remain same or the sign will reverse. So if the number is positive, inequality stays same. If number is negative, inequality changes. The type of number doesn't make a difference. It can be a positive number, it can be it can be an integer, it can be a fraction, it can be a rational number, it can be a rational number. It's perfectly fine. But the important part is the sign, not the value. On the other hand, in addition subtraction, it doesn't make a difference whether the number is positive or negative. It is going to stay same, so you don't have to worry much about it. Okay. Now there is going to be a polynomial inequality. Now what is polynomial inequality? So for example, I have a format of x minus 1 into x minus 2 into x minus 5, and let's say I'm talking about that is less than 0. Okay, now I need to find out the range of x, right? So what is the approach that I'm going to take? So first of all, figure out at what values of x this function becomes 0. Okay, so it becomes 0 at 1, it becomes 0 at 2, it becomes 0 at 5. So I'm going to get 3 values where the function becomes 0. Now pick any number that's greater than 5. Let's say 6, or if you want, you can take 10 as well. So let's take 10. So 10 minus 1 is a positive number. 10 minus 2 is again a positive number. 10 minus 5 is again a positive number. So positive into positive into positive is going to be positive, right? So I'm not looking at this sign. It is less than 0 or greater than 0. I don't bother about it. So positive into positive into positive is going to be positive. So if I'm going to pick a number that's greater than 5, it is going to be positive. Then what you are going to do, you are simply going to alternate the sign. So this is positive, this will be negative, this is positive, this will be negative, and this is how the sign goes. Okay. Now, what is my job? Now I'm going to look at this. Is it greater than 0 or less than 0? It is less than 0. So less than 0 means negative. So in which range I'm going to get a negative value? So first of all, I'm going to get negative value between 2 to 5. Second, I'm going to get negative value in less than 1. So it means I can say x is less than 1 or x lies between 2 and 5. And that's how I'm going to get the answer of this question. So whenever you see the inequality, your job is to solve it like this. Okay. Now let me take another example. So for example, I have question like this. X square is greater than 4. More likely you are going to get a question like this, not like this. Now, what is it I'm going to do? So first of all, I am going to write it as x square minus 4, and that's greater than 0. Okay. Now I'm going to factorize x minus 2 into x plus 2, and that's greater than 0. Okay. Now just write it as minus 2, 2. So it becomes, this function becomes 0 at minus 2. This function becomes 0 at 2. Now pick any number that's greater than 2. Let's say 5. So 5 minus 2 is a positive number. 5 plus 2 is a positive number. So positive into positive becomes positive. So this is a positive value. Then again, what we have learned, alternate the sign. So this is positive, this will be negative, this will be positive. Now what I'm looking for, is it greater than 0 or less than 0? I'm looking for greater than 0. So in which range I am going to get greater than 0? So it means x should be greater than 2, right? As well as x should be smaller than minus 2 in this range. So my answer of this question is going to be both the ranges. Either x should be greater than 2 or x should be smaller than minus 2. And this is the approach that we are going to carry to solve these kind of questions. Okay, now let's see what kind of questions we are going to see in the exam. Now this, for how many integers this statement will the inequality this be satisfied? Okay, so whatever we have learned just now, I'm going to use the same thing to solve this question over here. So first of all, n minus 5 into n minus 10. Multiply both of them. So n into n is n square. N into minus 10 is going to be minus 10n. Minus 5 into n is minus 5n. Minus 5 into minus 10 is plus 50. Minus 3n plus 6, and that's less than equal to 0. Okay. X square n square minus 18n plus 56 and less than equal to 0. Now I can factorize it n minus 14 into n minus 4. 14 fours are 56, right? So that is less than equal to 0. Now at what value of n the function becomes 0? It becomes 0 at 4 as well as it becomes 0 at 14. Okay. Pick any number that's greater than 14, let's say 20. 20 minus 14 will be positive. 20 minus 4 will also be positive. So positive into positive will give me positive. Now alternate the sign. So this is positive, this will be negative, this will be positive. Now what I'm looking for, I'm looking for less than. Less than means this range. Less than means, less than 0 means negative. Where I'm seeing negative between 4 and 14, right? So x should be lying between 4 and 14. So how many integers we are talking about? We are going to talk about 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So 1, 2, 3, 3, 3, 6, 6 plus 5, 11. So how many integers we are going to talk about? 11 integers, and the answer of this question is going to be 11. So whenever you are going to see this kind of question, your job is to write it in the factorized form and get the answer accordingly. Okay. Now let's move on to the next question. What does it say? Now it says that a and b are integers such that this, then the largest possible value of 2a minus 6b is. Okay. Now what is the approach we are going to take? Okay. If I am going to look at the first question, first part, this. So first of all, this is a quadratic function, right? And I can't factorize because I don't know the value of a. Okay, again, this is, I don't know the value of b. Can I factorize it? No. Okay. So now we have some trouble. Okay. So first of all, I am going to see this question and think what I can think of. So this is a quadratic function. The first one is a quadratic function, right? We have already done quadratic function in the previous session, right? And this quadratic function, the first quadratic function is always positive. right? And when quadratic function is always positive, when d is less than 0. When d is less than 0, so I'm going to use the same thing. So what is the value of d? So d is b square, so in this case minus a whole square minus 4, a is 2, c is it is 2, and c is also 2. B square minus 4ac is less than 0. A square minus 16 is going to be less than 0. So I can say that it is going to be a minus 4 into a plus 4, and it is less than 0. So from here, number line minus 4, 4. So plus minus plus. So a should be lying between minus 4 and 4. This is what we got. Now, because it says a is an integer, so the possible values of a are going to be minus 3, minus 2, minus 1, 0, 1, 2, and 3. These are the possible values of a. Okay. Now question is talking about what is the largest value of this, 2a minus 6b. So if I want to maximize this, this is positive, it means a should be maximum, so value of a should be 3. Now b should be minimum because b comes with a negative sign. So b should be negative and b should have the lowest value, then only I'm going to get my answer. Okay. Now the second equation, what does it say? So it says x square minus bx plus 8, that's greater or equal than 0. So again, d should be less than equal to 0. Okay. Okay. So what I'm going to get? I'm going to get b square minus 4, a is 1, c is 8, and that's less than equal to 0. So I can say that b square minus 32, and that's less than equal to 0. Okay. So b minus 4 root 2 into b plus 4 root 2. Because whenever you are solving inequality, always remember that your job is to figure out how to write it in the factorized form. Okay. Okay. So now what is going to happen? What I'm going to do? So it is the values are going to be 4 root 2, 4 root 2. So, and we are going to get this range. So b should be lying between minus 4 root 2 to 4 root 2. Okay. So what is the value of root 2? What is the value of root 2? Root 2 is 1.4 around. 1.4 into 4 is 5.6, right? And I know b is an integer. It means b should be lying between minus 5 and 5. Right. So value of b, minimum value of b, I was expecting the largest, I was looking for the largest value of a, I was looking for the smallest value of b. What is the smallest value of b? That's going to be minus 5. So 2a means 2 into 3 minus 6 times smallest value of b is minus 5. So this is going to be 6 plus 30. So it comes out to be 36. So smallest value of largest value of this function that is possible is going to be 36. And that's how we are going to get the answer of this question. Now let's move on to the next question. Now, what does it say is that m and n be natural numbers. Natural means positive integer. It can be 1, 2, 3, 4, 5, 6. It can't be 0. It can't be negative. Okay. And n is even. That is also given to us. Okay. And question is talking about this one. Now, 3 inequalities are given to us. The first inequality is 0.2 m upon 20, 0.5. This is first inequality. Second inequality, I would say n upon 11, 0.2, and 0.5. Okay. Third one is n upon, sorry, it's not m upon n, it's n upon m is greater than 0.2 and less than 0.5. And this is what question is talking about. And question is saying what is the value of n minus 2n. It means I need to have a definite answer. If there are multiple possibilities of m and n, then in every case answer should be same. Otherwise there is going to be only one possibility, because if question is not talking about what is the possible value, question is saying what is the value, right? So what is the value means I need to have a definite answer, then only I can match my answer. Okay, so I am picking up the first inequality, that is 0.2 lies between m upon 20 upon 0.5. So I'm going to multiply everything by 20, right? So I'm going to multiply everything by 20. So from here I'm going to get 20 into 0.2 is going to be 4m, and it is going to be 10. So what are the possible values of m? That is going to be 5, 6, 7, 8, and 9. Okay, that's what I got. Now I'm going to look for this. It says 0.2 is less than n upon 11, 0.5. Multiply everything by 11. So I'm going to get 2.2 n and 5.5. So n should be greater than 2.2. It should be less than 5.5. So possible values of n are going to be 3, 4, and 5. Okay. Okay. But it says that n is even. It means n cannot be 3, n cannot be 5. The possible value of n is 4. Okay. So what I'm going to get? I'm going to get m minus 2 minus 2 into 4. So it is going to be m minus 8. Now, even if I solve the question or not solve the question, I can directly get the answer. And why? How it is. M is 5. So 5 minus 8 is negative, right? There is no option that is negative. 6 minus 8, that's also negative. 7 minus 8, that's also negative. 8 minus 8 is 0, not in the option. 9 minus 8 is 1. There is only one possible value of n upon m, that is going to be 1. Okay, now we are going to check whether m is really 9 or not. Okay, so n is 4, m is this 0.2, 0.5. Now if m is 5, so 4 upon 5 is 0.8, not in the range, so m cannot be 5. 6, 4 upon 6 is what? That is going to be 2 by 3, or I would say 0.66, not in the range of 0.2 to 0.5. 4 upon 7, definitely greater than 0.5, so rejected. 4 upon 8, equal to 0.5, but the inequality sign is less than, so rejected. 4 upon 9 is 0.444, so that satisfies the value. So how many values of n we are going to get? 1. How many values of m we are going to get? 1. So 9 minus 8, that comes out to be 1. So what is the possible value? That comes out to be 1 only. Now if you got till this point that n is 4, you got your answer, because if n is 4, then m minus 8. Okay, m minus 8, and the options are 1, 2, 3, 4. M cannot be 10. So, and what is the maximum value of m? That is 1. So, sorry, that is 9. So, 9 minus 8 is 1. In all the other possible values of m, the value of this is either 0 or negative. I don't even need to calculate this. I can directly get my answer by doing that. Okay. Now, let's move on to the next question. I hope everyone understood what is the approach. Now, let's move on. What does it say? X and y be positive integers such that x plus y is equal to n, and x lies between 2 and 10. Okay. Now question says x and y are integers. It means the maximum possible value cannot be 10. The maximum possible value of x is going to be 9. So x should be smaller than 9, x should be greater than 3. This is what we have. Okay. Now similarly, y is also an integer, positive integer. So y is greater than 14. So smallest value of y is going to be 15. Okay. And less than 22. Okay. Now n is equal to x plus y. So I'm just going to add both the values. So x plus y comes out to be how much? The range is going to be 18 to 18 to, that is going to be 31. Okay. So the range of n is 18 to 31. Okay. But what is the problem here? Question says n is greater than 25. So if n is greater than 25, so n is greater than 25 and less than equal to 31. How many possible values we got? 26, 27, 28, 29, 30, and 31. How many values we got? 1, 2, 3, 4, 5, and 6. 6 values are possible, not more than 6. So how many distinct values of n are possible? That is going to be 6. And that is the simple approach. That's the approach we are going to follow in the exam. This is how we can get the answer very quickly. Now the problem is why I am taking greater than 3. Now try to understand. If x is greater than 2, so x can be 2.2, x can be 2.1, x can be 2.8. But why I'm taking 3? Because x is an integer. So if x is an integer, it means x cannot be 2.2. The smallest value of x is going to be 3. That's the reason I'm just working with the integral values of x. I'm working with the integral values of y. Otherwise, if this is written, this I cannot write it like this unless this condition is given. Always remember, don't think that if y is greater than 14, that does not mean y is going to start from 15. Y can be 14.4, but in this particular question it says y is an integer. That's the reason smallest value of y is going to be 15. Okay, now let's move on to the next question. What does it say? The number of distinct values of n is this. Okay, so something is given to us, this and this, and so I would say that a upon b is less than 0. Okay, so that's what is given to us. Okay, now what I can say, uh, one number divided by second number is negative. It means one number is going to be positive, second number is going to be negative, or the first number is negative, second number is positive. So there are two possibilities. I am going to work with both the possibilities. So let's say uh, a is negative and b is positive. What is a? That is 4 minus log base 2n is negative. So it means log base 2n is greater than 4. So n is greater than 2 power 4. Means n is greater than 16. Okay. Now second is b is greater than 0. It means 3 minus log 4 n is greater than 0. It means log base 4n is smaller than 3. It means n is smaller than 4 power 3, or I would say 64. Okay, so from here I can say that n is greater than 16 and less than 64. Okay, fair enough. This is the fair assumption that we are going to get. So in the first case, we are going to get certain values. How many values we'll count later. Okay. Now it is going to be a is positive. It means 4 minus log 2n is greater than 0. It means log base 2n is less than 4. Okay. So it means n should be less than 2 power 4, or n should be less than 16. Okay, that's fine. Now second is log base 4n, 3 minus log base 4n is less than 0. It means log base 4n is greater than 3. It means n is greater than 4 power 3 or 64. Now in this inequality I am getting n is less than 16 as well as n is greater than 64. How can a number be greater than 64 and less than 16 at the same time? Can it happen? No. So basically this inequality will not give me any possible arrangement. So I am not going to take this, and I am going to get the answer like this only. So what I'm going to get, so how many values we are going to get? Smallest value is 17, largest value is 63. So how many numbers between 17 and 63, both inclusive? 47. So my answer of this question is going to be 47. Okay. Now let me take an alternate approach. we have you already seen inequality, we have already seen the questions that we have solved. So 4 minus log 2n upon 3 minus log, that is going to be log base 2n, uh, or I would say it is going to be 1 by 2, and that's less than 0. Fair enough. So basically it is log 4. So the power 2 goes to denominator. Okay. So what I am going to do, 4 minus log 2n upon 6 minus log 2n is less than 0. Okay. And this 2 goes to numerator. Okay. I'm just going to divide it by 0. So I am going to get 4 minus log 2n upon 6 minus log 2n, and that is less than 0. And this is what we get. Okay. Now let's call it x. So 4 minus x upon 6 minus x is less than 0. So I am going to solve this question like we have solved the previous questions. So what are the values? One is 4, second is 6. Okay. Now it is, so I'm going to put a value that's greater than 6, let's say 10. So 4 minus 10 is negative, 6 minus 10 is also negative, negative, negative is positive, right? So positive, negative, positive. This is what we have. Now because it is written, it means I am going with a default condition that x can never be equal to 6 as well as x can never be equal to 4. Because if x becomes 4, this will be equal to 0, not possible. If x becomes 6, then the function will be not defined. So it means the default condition is x cannot be 6, x cannot be 4. Okay. Now it is less than 0. So if it is less than 0, it means I'm looking for a negative range where I'm going to get between 4 and 6. It means x should be lying between 4 and 6. And what is x? Log base 2n lies between 4 and 6. So it means n should be lying between 2 power 4 and 2 power 6. So n should be lying between 16 and 64. And how many numbers that are going to lie between 16 and 64? That is going to be 47, and that's the answer of this question. So this is also an alternate approach to solve this question. If you want, you can use that logic, the previous one we have discussed, or this is a very generic thing that we have done at the start of the session itself. Now let's move on to the next one. What does it say? The minimum possible value of this. Okay. Okay. So now, okay. So this is a function. Fair enough. Now it is a square minus 2ab plus b square. I'm going to do a couple of concepts for this particular question. It can be written as a minus b whole square. But the thing is, it can also be written as b minus a whole square. Now what you are going to write? A minus b whole square or b minus a whole square? The thing is, when you are going to write a minus b whole square or b minus a whole square, if a is greater than b, it is going to be a minus b whole square. If a is smaller than b, it is b minus a whole square. Okay. So this is something that you need to know. This is something you need to remember. Okay. Now x is less than 3. Okay. So I'll come to that. Now the second concept that we are going to use, that x plus 1 upon x is always greater or equal than 0 if x is positive. This is something that we need to know. The smallest value of this, x plus 1 upon x, is always going to be 2 only. Now, what I am going to do, I am just going to break this statement as x square minus 6x plus 9 plus 1 upon 3 minus x. Now, if you see, it is x whole square as well as it is 3 minus x whole square. So what I'm going to do? I'm going to write it as x minus 3 whole square or 3 minus x whole square. I'm going to write it as 3 minus x whole square because x is smaller than 3. Okay, so this comes out to be 3 minus x whole square plus 1 upon 3 minus x. So this gives me 3 minus x plus 1 upon 3 minus x. Now let's say 3 minus x equal to y. Okay, so what is this function we are going to get? Y plus 1 upon y. We have already seen that y plus 1 upon y is always greater or equal than 2. So what is the smallest possible value of this function? That's going to be 2. So answer of this question is directly going to be option A. And this is the approach we are going to take to solve this kind of question. This is the standard thing that we can do. Okay, and with this, we conclude this session. If anyone has any doubt, you can ask me a question. You can drop a question in the comment box and ask me anything. I'll respond as soon as possible. Thank you.